What is edge computing? Your data travels thousands of kilometers just to come back in milliseconds. But what if it didn't have to? A self-driving car is moving at high speed on a busy road. Suddenly, a pedestrian steps in front of it. The car has only milliseconds to react. In that moment, there is no time to send data to a distant server, wait for processing, and receive a response. The decision must be made instantly. This is where edge computing becomes not just useful, but essential. Edge computing is a modern approach to computing in which data is processed closer to where it is generated, rather than being sent to a central server or cloud. In traditional systems, when a device collects data, that information is transmitted to large data centers where it is processed and then sent back. While this system works well for many applications, it introduces delays because of the distance data must travel. Edge computing solves this problem by bringing the processing power closer to the source of the data. This simple shift has a powerful impact. It reduces latency and improves speed dramatically. To understand edge computing more clearly, it is helpful to compare it with traditional cloud computing. In cloud computing, data travels from a device, such as a smartphone or sensor, across networks to centralized servers that may be located far away. These servers perform the necessary computations and then send the results back to the device. Although this process is efficient for tasks that are not time-sensitive, it can become a problem in situations where speed is critical. Even a small delay can affect performance or lead to serious consequences. Edge computing changes this model by processing data locally, either on the device itself or on nearby servers known as edge nodes. These nodes are placed closer to the user or the data source, which significantly reduces the time it takes to process and respond to information. As a result, systems become faster, more efficient, and capable of real-time decision-making. The importance of reducing latency cannot be overstated. Latency refers to the delay between sending data and receiving a response. In everyday applications like browsing the internet or streaming videos, a slight delay may only cause minor inconvenience. However, in advanced systems such as autonomous vehicles, healthcare devices, or industrial automation, even a delay of a few milliseconds can be critical. Edge computing ensures that these systems can operate quickly and reliably by minimizing the distance data must travel. One of the most powerful examples of edge computing can be seen in self-driving cars. These vehicles rely on a network of sensors, cameras, and artificial intelligence systems to navigate roads safely. They must constantly analyze their surroundings, detect obstacles, and make decisions in real time. If these decisions depended on cloud computing, the delay caused by data transmission could be dangerous. By using edge computing, self-driving cars process data directly within the vehicle, allowing them to react instantly and operate safely. Another area where edge computing plays a crucial role is in smart devices. Today, billions of devices are connected to the internet, forming what is known as the Internet of Things (IoT). These devices include smartphones, smartwatches, home assistants, security cameras, and more. They generate vast amounts of data every second. Sending all this data to the cloud for processing would not only slow down performance, but also increase network congestion and costs. Edge computing addresses this issue by enabling devices to process data locally or within nearby systems. This allows for faster responses and a smoother user experience. For example, a smart home system can use edge computing to control lighting, temperature, and security in real time. When you walk into a room, sensors can instantly detect your presence and adjust the environment according to your preferences. Similarly, voice assistants can process commands more quickly, providing immediate responses without relying heavily on cloud servers. Edge computing is also transforming urban environments through the development of smart cities. Cities around the world are using connected systems to manage traffic, monitor infrastructure, and improve public safety. These systems rely on real-time data from sensors and cameras. If this data had to be sent to centralized servers for processing, it could result in delays and inefficiencies. Edge computing allows cities to process data locally, enabling faster decision-making and more effective management of resources. In healthcare, edge computing is making a significant impact by enabling real-time monitoring and faster medical responses. Wearable devices and medical sensors can track vital signs such as heart rate, blood pressure, and oxygen levels. With edge computing, this data can be analyzed instantly, allowing doctors and healthcare providers to detect potential issues early and take immediate action. In emergency situations, this can save lives by providing critical information without delay. Industrial and manufacturing sectors are also benefiting from edge computing. Modern factories use advanced machinery and sensors to monitor production processes.
These systems generate large amounts of data that must be analyzed quickly to ensure efficiency and prevent failures. Edge computing allows manufacturers to process data in real time, predict equipment failures, and reduce downtime. This not only improves productivity, but also enhances safety in the workplace. Another important advantage of edge computing is its ability to reduce bandwidth usage.
By processing data locally, only the most important information needs to be sent to the cloud. This reduces the amount of data transmitted over networks, lowering costs and improving efficiency. It also helps in situations where internet connectivity is limited or unreliable, as edge devices can continue to function independently. Security and privacy are also improved with edge computing. Since data is processed closer to its source, there is less need to transmit sensitive information across networks. This reduces the risk of data breaches and unauthorized access. For industries that handle sensitive data, such as healthcare and finance, this is a major benefit. Edge computing is closely linked with other emerging technologies, particularly 5G networks and artificial intelligence. The rollout of 5G technology is providing faster internet speeds and lower latency, which enhances the capabilities of edge computing. Together, these technologies enable real-time applications that were previously impossible. For example, augmented reality, virtual reality, and advanced gaming experiences can now operate smoothly with minimal delay. When combined with artificial intelligence, edge computing becomes even more powerful. AI systems can analyze data locally, allowing devices to make intelligent decisions without relying on cloud processing. This combination, often referred to as edge AI, is being used in applications such as facial recognition, autonomous systems, and smart surveillance. Despite its many advantages, edge computing also faces challenges. One of the main challenges is the limited computing power of edge devices compared to centralized data centers. While technology is improving rapidly, edge devices still have constraints in terms of processing capacity and storage. Another challenge is managing a large number of distributed devices, which can be complex and require advanced systems for monitoring and maintenance. Security is another concern, as having multiple edge devices increases the number of potential entry points for cyber attacks.
Ensuring that all devices are secure and updated is essential for maintaining system integrity. Additionally, the cost of setting up edge infrastructure can be high, especially for large-scale deployments. However, these challenges are being addressed through ongoing research and technological advancements.
As hardware becomes more powerful and software becomes more efficient, the limitations of edge computing are gradually being overcome. Companies and organizations around the world are investing heavily in this technology, recognizing its potential to transform industries and improve everyday life. Looking ahead, the future of edge computing is incredibly promising. As the number of connected devices continues to grow, the demand for faster and more efficient data processing will increase. Edge computing will play a key role in supporting this growth, enabling new applications and innovations. In the coming years, we can expect edge computing to become a fundamental part of modern technology. It will support advancements in areas such as autonomous vehicles, smart cities, healthcare, and industrial automation. It will also enable new experiences in entertainment, communication, and education. Edge computing represents a major shift in how data is processed and managed. By bringing computation closer to the source of data, it reduces latency, improves speed, and enables real-time decision-making. This makes it essential for technologies where every millisecond matters, such as self-driving cars, smart devices, and real-time systems. Edge computing is not just an improvement, it is a transformation. It changes the way technology operates and opens the door to a future where systems are faster, smarter, and more responsive than ever before. As this technology continues to evolve, it will redefine how we interact with the digital world and shape the future of innovation. Subscribe now because the future is moving fast and you don't want to miss it.